Hello again. Welcome to another lesson in geometry. Today we're covering section 3.3, proving lines parallel. Okay, so we're going to go in reverse. Last time we had parallel lines. We talked about the angles that were created from it. This time we have angles that are congruent. We're going to talk about how we use those to make parallel lines. Okay. All right, so our vocabulary here, write the converse of each statement. So statement is if you are cold and you wear a sweater. The converse is if you wear a sweater, then you are cold. Okay. If an angle is a right angle, it measures 90 degrees. If an angle measures 90 degrees, then it is a right angle. And the second one is definitely true because it's a good definition of a right angle, so it's reversible. So we learned that already, that the right angle definition was good. So the converse of a true statement is only sometimes true though. Okay, if it's always true, it'll make a good definition, but if it's sometimes, it doesn't work. Okay, so possibly if you wear a sweater, it might not actually be cold. Okay, all right. Vocabulary builder, exterior. So related words, exterior, external, and then the opposite, which is interior. So an antonym is its opposite. Definition, exterior means on the outside or in the outer region. Okay, so the exterior of lines L and M are on the outside and the interior is between the two lines. And then of course we have on the lines themselves. And then two lines crossed by a transversal form four exterior angles. So here's two lines. We cross them by a transversal, we get 1, 2, 3, 4 exterior angles. And that's because the interior is in here. Okay. All right, use your vocabulary. Underline the correct word to complete each sentence. So to paint the outside of your house, you buy exterior paint. Why paint it with interior paint? It won't work. The weather will wear it off quickly. The protective cover prevents the exterior of the book from being damaged. It doesn't stop the interior when you flip it open. In a diagram at the right, angles 1 and 7 are alternate. Let's see. This is the interior, so these are 1 and 7 are on the outside, so these are alternate exterior angles. Oops. Okay. In the diagram at the right, angles 4 and 5 are same side interior angles. 4 and 5 are on the inside of the two parallel lines. Okay. Underline the hypothesis and circle the conclusion in the following statements. So our hypothesis here is the lines do not intersect, and the conclusion is they are parallel lines. Remember, the if and then are not part of the hypothesis or conclusion. Okay. If the angles, oops, that was supposed to be underlined. So underline the hypothesis here. The angle measures 180, and the conclusion is it is a straight angle. All right, that concludes page 1. Let's flip it over and take a look at page 2. Okay, we have postulates 3.1 and 3.2, corresponding angles postulate and its converse. Okay, so the corresponding angles postulate says this. If a transversal intersects two parallel lines, then the corresponding angles are congruent. We learned this one last time. We used patty paper to show that this has always seemed to be true. Complete the statement for postulate 3.2. So postulate 3.2 is going to be the converse of this statement. So if two lines on a transversal form corresponding angles that are congruent, then the lines are parallel. So the converse is just flipping it around. So we're saying in our first postulate we learned last time, two parallel lines, angles, our corresponding angles were congruent, and now we're going in reverse. Corresponding angles are congruent, then the lines are parallel. Okay. So use the diagram below to place appropriate markings to show that angle 1 and angle 2 are congruent. All right, well, that's easy. We just put little marks like that. Now notice angle 1 and angle 2 are corresponding angles because they're in the same left side on the transversal T that cuts through R and S. Okay, so circle the diagram number 12 that models postulate 3.2. So what's going to show that our lines L and M are parallel? Well, if we're going to use corresponding angles, then this one won't work. These are alternate exterior angles. These are corresponding, so this will prove that the lines L and M are parallel. So if this was a true picture, then I would know L is parallel to M. Okay. All right. So here's a couple of quick notes here. Theorems 3, 4, 3, 5, and 3, 6. And you can guess these pretty quickly. They are the converse of the alternate interiors angles theorem. So this just says if alternate interior angles are congruent, then the lines are parallel. And then we have the converse of the same side interior angles theorem. So same side interior angles, they weren't congruent, they were supplementary. So if the same side interior angles are supplementary, then the lines are parallel. And then we have the converse of the alternate exterior angles theorem. And that's saying that if the alternate exteriors are congruent, then the lines are parallel. So we're just going in reverse of the three we learned last time. All right, use the diagram at the right to complete each example. So if angle 4 and angle something, then the lines are supposed to be parallel. Now this is based on 3.4. So 3.4 was the converse of the alternate interior angles. So we need to find 4's alternate interior. So this is 4, the alternate interior would be 8. So if 4 and 8 are congruent, then B and C are parallel. Okay. 3.5 was about same side interior, and same side interior is supposed to be supplementary. So if 3 and 8, which are inside B and C and on the same side, are supplementary, then B and C would be parallel. And then our last one was about alternate exterior. So let's erase here for a second. So alternate exterior was 1. It's going to be in the exterior on the alternate side, which is 7. So 1 and 7. So if 1 and 7 are congruent, then once again, B and C are parallel. So last section, we said, hey, if they're parallel, then these special congruencies happen. And now we're saying if those special congruent things are happening, then the lines also must be parallel. All right? Let's flip it over and do a little bit of work with that. Okay, on page 3, we have 3 problems here. Our first problem is about identifying parallel lines. And the question is, which lines are parallel if 6 and 7 are congruent? Justify your answer. So we have 2 sets of lines so we don't know who are the parallel lines and who are the transversals. Okay. All right, so 6 and 7 is the given. Okay, so that's what we are given. We want to prove some lines are parallel. Okay, so 6 and 7, let's see. That's here and here. 6 and 7 are alternate angles or same side. Well, I'm going to say same side. Okay, here's B, the transversal, and they're both on the same side of that transversal B. So they are same side angles. So 6 and 7 are what kind of same side? Are they corresponding exterior or interior? Well, that only makes sense if they are corresponding here, because one's inside and one's outside. So they're both in the bottom left if it's crossing these 2 lines. So they're both in the bottom left position. Okay, so since they're corresponding, we can use postulate, let's see, 3.2. Okay, to prove the lines are parallel. So remember, postulate 3.2 is the converse of postulate 3.1. So 3.1 said if the lines are parallel, the corresponding angles are congruent. And postulate 3.2 said if the corresponding angles are congruent, which we know 6 and 7 are congruent, then the lines are parallel. So using 6 and 7 being congruent, lines L and M are parallel. And the transversal that's cutting across them is line B. B cuts across L and M are parallel because when B cuts across it, 6 and 7 are congruent. All right, problem 2, writing a flow proof. So we've seen paragraph proofs and we've seen 2-column proofs. This is our first flow proof. All right, so flow proofs work the same, just writing it sideways and showing which ones go together to form something else. Okay, so given that angle 1 and angle 7, we want to prove 3 and 5 are congruent using a flow proof. All right, so given here, this is angle 1 is congruent to angle 7. And then we say angle 1 and 3 are the same. Well, 1 and 3 are going to be the same because these are vertical angles. So this is vertical angles are congruent. Okay. And then we say 3 and 7 are the same. Now, you'll see this written two different ways sometimes, transitive property or substitution. Transitive property, if we read it backwards, so A is congruent to B, B is congruent to C, so A and C must be the same. That's where 3 and 7 match up. Or you can just say, hey, we're substituting in here. So in place of, let's see, 7 is here. So in place of 1, we're going to put 3. So 7 stays from this part. And we replace this 1 with that 3 because 1 and 3 are the same. I'm going to go with transitive property. You'll see that more often in the answers for the book. But either one is fine. Okay. All right. So since 3 and 7 are the same, then we should know that 7 is the same as 5 by vertical angles. So 7 and 5 are the same. And let's see. So this one's easy to see. 3 makes 7. So that's A turns into B. And then 7 makes 5, so B turns into C. 7's the same in both. Therefore, 3 and 5 are the same. And this is once again going to definitely be transitive property of congruence. Okay. So transitive property of congruence. All right, so this gives me 3 and 5 being the same. Problem number 3 here. Determine whether lines are parallel. So given that angle 1 and angle 2 are congruent, we can use the converse of the alternate exterior angles theorem to prove it right away. So there wouldn't be any work. So 1 and 2 are alternate exterior. So we should be able to say, hey, those lines are parallel, we're done. Okay, we just use that. But they're saying, let's find a different way. So what's another way to explain R and S are parallel? All right, so we'll get this. Our given was 1 and 2 are the same. So this is our given. Okay, we can also say 2 and 3 are the same. And this is because vertical angles are congruent. Okay, and then we can say 1 and 3 are the same, and that's going to be transitive property of congruence. And you can see it, it's A makes B, B makes C, so this is A makes C. And then angles 1 and 3 are, well, let's see. They're both in the left side on the transversal T. So there's our parallel lines, R and S. T cuts across it, and they're both on the left side. So these are corresponding angles. And then which postulate can we now use to explain why R and S are parallel? So this is going to be, I'm going to write it out. If corresponding angles are congruent, then lines are parallel. This was postulate 3.2, if we're looking back. Okay, so postulate 3.2 tells us the converse. If the corresponding angles are congruent, then the lines are parallel. Okay, that's the converse of postulate 3.1. Let's flip it over and see what's on our last page. All right, on our last page here, we have one more problem and then the lesson check. So in our problem, it says, what is the value of W for which C and D are parallel? All right, so this is using some algebra. To figure this out, we're going to end up with an equation. So underline the correct words to complete each sentence. So the marked angles are on the same side of the transversal. So here's the transversal cutting across, and they're both on the left side of that transversal. By the corresponding angles postulate, CD are supposed to be parallel. So let's see, this is going to be, then the corresponding angles are congruent. Okay, so if the lines are parallel, so if C and D are parallel, then these two angles in corresponding positions should be congruent. So we can use that to help us. Since we know they're supposed to be congruent, we can take 3W minus 2 and set that equal to 55 and then solve it. So 3W would equal to 57. And 3 times 20 is 60, so that's 1 less. So this would be W is 19. Okay. And if I plug this back in, 3 times 19 is 57, and minus, 3 times 19 is 57, minus 2 makes 55. And this one's already 55, So we can see that they're congruent because they have the same measure. All right. We have a quick lesson check down here. Let's see. So as usual, pause the video, try these two problems yourself, see if you can figure them out, and then come back and check. All right, so this is a classmate says these two lines are parallel. So he thinks AB is parallel to CD, okay, given from what information is drawn on our picture. Circle the segments that are the sides of angle D and angle C. So angle D is formed from DA and DC. So that's these two. And angle C is formed from CB and CD. There's CB, but CD is not on here. Now, where did your classmate make the mistake? All right, so this is a little bit trickier. So these two are same side anterior, but not for what he's thinking about, okay? So he wants to prove that the two red ones are the same. That's not going to work for us. They're not on the same side of a transversal that cuts through the two red ones, okay? So what's really going on is, and what he's confusing with, these are the two parallel ones, and this one cutting across it is the transversal. Then we could say that AD and BC are the same. So he has his parallel lines mixed up because 83 and 97 are same side interior for DC, it's transversal. Therefore, AD is parallel to BC, not what he wrote. Okay, so we had to fix it a little bit. All right, so check off the vocabulary words that you understand. Hopefully a flow proof, okay, just the same as a two-column proof or two-step or a paragraph proof. What we write, it's going sideways, showing which two make something else, or 3 or 4, whatever it is. Two-step proof, we've been doing those for a while, okay? And parallel lines, you've been looking at those for a while, so that shouldn't be a problem. And then how well can you prove the lines are parallel? So you should be getting over here by now. Okay, this is our second day of kind of working on this. All right. Thank you. I'll see you in class next time, and we'll practice this a little bit.